So let's start on question number 5 then. Would anyone like to read it?
I can.
Okay.
Alright, a four-sided die has 4 possible outcomes for each roll.
Okay.
1, 2, 3, or 4. Calculate the mean of this discrete random variable.
Alright.
So, does that mean on each side of the four-sided die it has like 4 options? Or
Yeah, so it's meaning that there's only 4 sides to it, and that each number, there's like 4 different numbers, of course. So on the reading, it shows like actually how they did that with like regular variables and like
yeah.
yeah. So if we just pretty much copy what they did, we should be able to find the mean.
Yeah.
So let's
Which was
calculate
actually
that.
really easy to find, so.
Yeah. And I mean, since it's 4 2, because I like kind of looked at it before, I was like, that's luckily not 1/6, but 1/4. So that's good.
Yeah, that is good. Okay, let's do that then.
Let's calculate that for a second and regroup.
What is the mean? So, let's see. Are you guys doing the one where you're multiplying the value by the probability, or are you just...
You're multiplying what again? Say that again.
Is this the one where you multiply the value of like numbers 1, 2, 3, and 4 by the probability and then divide it by? Okay.
And I don't think you divide it, you just times like, so the value times the probability. And that you add them all together and it should equal the mean.
Okay.
So, yeah, let me know when you guys are done because I'm typing. I'm on my husband's computer and I still don't know it very well, so I'm
Okay.
slowly but surely doing this.
Calculator speaks. Times. Point 5. Sorry, I'm thinking out loud.
No, you're good. You're good.
Easy enough.
You guys gotten something?
What did you get?
Okay. Do you guys have it yet?
I got 2.5, is that right?
That's what I got.
Yeah.
That's what you got, Hannah. Hey, I think it's right. Let me check.
Okay.
Let me get it up.
Good idea. I forgot how we could do
Yeah. Hopefully we all got it right, because like if we're doing it right and we already figured it out, then that's good. So let me get this loaded. Hold on. Okay, perfect. Yeah, it's 2.5.
Okay.
Okay. So the second one though is the standard deviation. And that one, after I was calculating it, I started scrolling down and I was like, oh crap. So, yeah.
So you just, let's see. You take...
So like for the first one, it'd be 1 minus 2.5, right? And that's squared.
Yeah, squared.
And then times 0.25.
0.25.
Yeah. So we'll just need to figure out each of those. Okay.
Okay, I see. That's good. I wish I had a piece of paper.
Or it's minus 2.5, comma. And was it plus? Oh, times. Times 0.25. Right?
Mhm. Yeah, times.
Okay, so that's point.
What did you get for the first one?
0.5625.
Cool. I'm doing it on my iPhone, and the calculator's kind of weird. So I just
I know.
right.
Okay, let's double check it really quick because I'm like nervous. I've never been good at standard deviation, honestly.
I've never even heard of it, so don't worry.
Got it. No worries, guys. We can do it.
Yeah. I was excited when I was doing the homework. I'm like, yeah, I've got it. But I do have a question for you guys afterwards, so
Okay.
that'll be where it gets fun.
Okay, I double checked it. I did get 0.5625 again. So if anyone gets something else, let me know.
Oh, I see what I did wrong. Okay, I forgot to square it. That makes more sense.
Oh, okay. Okay.
Like, that doesn't make any sense. By subtracting. Okay, much
Sorry, guys. I sound awful.
better. No, you sound. Are you sick?
Yeah, I'm still sick.
Aw.
I just can't seem to get over this cold. And of course, like, I'm training in all these new departments, and so it's like I'm
Yeah.
around sick people and people who are trying to get better come towards me, and I'm like, I'm just so sorry. Let's see, okay, and then for 3. For the second and third number, did you guys get 0.0625?
I
Maybe?
haven't gotten it yet.
Okay, let me know.
Sorry. Mm. Okay.
Okay, that makes sense.
Okay. And then you said you multiply it by the. Okay.
Oh.
For the first one, for the side one, did you get 0.5625 like as the?
Yeah, that was the first for like 1 minus 2.5 squared times 0.25, right?
Okay, just making sure I remember basic math.
No, you're doing good. You're good.
Okay. Yeah, and then. So what did you get for like the two middle ones? Did you get 1.125?
I got 0.0625 for both of them.
Oh, okay.
Yeah, did you get that, Hannah?
Yeah.
Okay.
Let me see if I just did it wrong. So 0.5. Wait, hang on a second. Okay, never mind. I see. This calculator's just really dumb. Yeah, I got that too. Okay.
Okay. So yeah, because I got so we already determined that the first variable is 0.5625. Second and third variable are 0.0625. And fourth variable is 0.5. Did you guys get 0.5625 again?
Yeah, I did.
Is that correct? Okay. Because I know when we add those four together, it should equal the sample variance.
Yeah.
And then you find the square root, and it equals the standard deviation.
Right.
Yeah.
Did you work out have you done through the standard deviation?
Yeah, I squared it because I added it all together already.
Did you get 1.118?
Yep. That's exactly it. What about you, Brianna?
I'll be there in just a second. Sorry.
No, you're good. You're good.
I should go grab another calculator.
Do you have a phone?
I need to go grab my phone. It's downstairs.
You should, because did you know actually, like the statistics calculator, if you just turn it like this way,
Oh yeah,
you
you're
can get it?
right.
Yeah, it's really cool.
What answer did you guys get? Did you say you got 5625? Oh wait,
Oh,
then you
you
gotta
mean
get
for
the
the full variables?
then you gotta get the
Or
square
for,
root of that.
okay.
Did you get 75?
So for the first and the fourth, it came out to 0.5625, and then the middle two numbers were 0.0625, and then
Mm-hmm.
add them all together to get the sample variance.
Okay. Let's see. Plus. And then that's 0.625. Did you get that?
For the sample variance, I got 1.25.
Yeah, 1.25 was
I don't
the.
know what I'm doing wrong.
So, do you want to just screen share really quick and we can figure it out?
Yeah, I think it's just the calculator. It's just kind of like it's like the really dinky computer one. Can I go run and grab my phone real fast?
Yeah, no, go for it.
Okay, I'll be right back.
Go for it. I'm glad you got the same answer as me, though, Hannah.
Me too. Hey, so for the homework, or no, this isn't the homework. This is just notes, right? Do we have to turn this in? Are we supposed
No.
They're just
no.
notes for ourselves?
Yeah. It's like to help prepare us for like this quiz that we're gonna take together.
Okay, cool. I just didn't know if we had to turn it in. Do we have to turn in our homework? I've never done that either.
Yeah. The
Okay.
homework, if you see like there's like a homework panel like right below the group meeting. You take a quiz from the homework that you do. So I mean, I guess
Yeah,
sorry,
I'm taking
you
the
don't have to turn
quiz.
it in.
Oh, okay, yeah, that's what I was asking. So I've taken the quiz, but I've never turned in like
Yeah.
the homework sheet.
Yeah. Sorry, I was like, I know the homework ties in somehow. It's like there's that spot. But yeah, I guess it's all just to prepare us for the quizzes, even though I feel as though like the homework isn't the same as what's on the quizzes, so I'm kind of almost blindsided when I take it.
Yeah, I am like so bothered by because on both of the the homework quizzes I've missed one, and I hate that you can't see what you miss. Like it really bugs me
Yeah.
because it like eats at me. I'm like, oh, which one was it? But
Yeah. Or how can
Okay.
you fix it? Yeah. Oh, you're back. Hey.
Okay. Yeah. All right. Why don't you screen share with me and show me because I'm still not getting the same answer.
No, you're good. Do you want me to do that, or Hannah, do you want to do it?
I wrote it on a piece of paper. I can show you my.
Okay.
Yeah, do
That's
it.
fine.
For it.
Hang on. Let me. Okay. And then, oh wait, I did get that answer. Never mind.
And then the square root, yeah, the 1.25.
Okay. Yeah, I did get that.
Oh, okay, cool.
I just thought I got it wrong.
Cool. So you got
Alright.
1.118.
You're good.
Yeah, I did.
Don't worry, guys. We got it. All right. Yeah.
Okay, cool. Yeah, I just checked it and it's good.
Let me double check and make sure we got it right at least. Okay. Yeah, we did. Perfect. Okay. So where am I right now? Okay. So other than that, now like since we've gotten the homework done, for the preparation, let's take the quiz together.
Okay.
Or do you have any? You have a question though, Brianna, right?
Yeah,
Brianna?
I did.
Sorry, I went to
Okay.
a baby shower and the lady's name was Brianna. So I keep calling you Brianna.
No, that's
Sorry.
fine. Okay, I'm gonna maybe just screen share with you so you can see what I. 1 second. So you can see what I'm talking about. Okay. So I was taking notes during it, and whenever we were doing it was talking about the mean. You see how they multiply it and add it all together and then they divide by that number? Is that just for the sample mean and then actual mean is different?
Wait, so are you gonna screen share for that?
Oh, I thought I just did.
Oh yeah, it was just you. Sorry.
Oh, sorry. Okay. Entire screen. Okay. Okay, can you see that now?
Okay, talk again
Oh.
for a second.
Okay. So, you know how we just like what we did was we just multiplied it and added it up like 1 times 0.25. But here in this one where they're talking about the sample mean, they're dividing it also by 6,000 by the sum. Is that just because it's the sample mean and not the actual like population mean?
Hold on. I'm gonna look it up.
So that's the only thing I can come up with.
I'm trying to find where that's at really quick. Actually, oh.
Yeah.
Okay, so it's just saying that's one way of doing it too.
Okay.
So you can either do it the way that we did it, which is calculating each individual thing together and then adding it up. What it's also doing too is instead of you timesing the value by the probability, you're timesing the value by how many times it showed up.
Oh, so it's like the actual observation.
Yeah, the
So
actual
it's
number of
different.
times that they picked it up, I guess, or like, how would you say
Okay.
that? Like, yeah.
Okay, that makes sense. And this one we did was just probability too. Okay. It seems like I always got the same answer either way I did it, so.
Okay. Good.
Okay.
No worries. Yeah. Okay. Good. Any other questions?
That was it.
I think I'm good.
You're good? You guys want to take a quiz?
Yeah, I do.
Okay. Let's do it. I'm going to mark the individual prep done. Okay. All right. Full screen.
See if I can find it.
You guys press start?
Yes, right now.
Okay, I did too. Okay, here we go. You can answer the first two on your own.
Okay.
Okay, and then once you get to number 3, I can read number 3 and then we can go from there.
Okay.
So, it says human blood can be classified into 4 basic types: O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Use the data to answer the following questions. The blood types and the proportions given in the table above define a probability distribution.
So
That's
is that
actually a really hard
follows
question.
the rules? So like, they all need to add up to 1, right?
Yeah, so let's figure that out. That just saved my butt because I was like, crap, I don't know how we're going to talk about that. How
Yeah.
can we tell if it really is or not? Thanks, Hannah. Or was that Brianna? I don't even know.
No, that was Hannah.
Thanks, Hannah. Okay, so it fulfilled that. It all equals to
So
1.
it should be true, I think.
Yeah.
Yeah. I don't remember the term probability. I think I remember we're hearing about distribution, but not in that way.
Yeah.
Probably true.
I guess. Okay, does someone read number 4?
Yeah, I can.
Okay.
What is the probability that a randomly selected person in the United States has type O blood?
Probability.
It's like,
So that 0.45.
yeah.
0.45. Yeah.
At first I was expecting something hard, and then I was like, wait, I'm okay.
Yeah, that's sort of easy.
Okay. And then,
Number 5.
yeah.
What is the probability that a randomly selected person will not have type O blood?
Okay.
So that's just add it all up.
1 minus 0.45. 55. Or, yeah, tell me what you get.
Yeah.
Zero. Yeah, that's what I got.
Okay. Good. All right, and I'll read number 6 if you guys are ready for that.
Mhm.
All right. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. What the freak? Bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrated the identification of a specimen. Woo! Hold on 1 second, guys.
Okay.
Hi. Oh, not today, but thank you so much. Yeah. My tamale lady just showed up. Cool. Okay. So where was I at? Okay, 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dog guesses at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient?
Be 1 out of 7, which, right?
Right? Yeah. Ah!
0.14?
Yeah, so we're into 3 decimal places.
Oh, is it 3?
Yeah, 0.143.
So 0.143. Okay. 0.143. Okay. Then Hannah. Was it Hannah? Yeah.
Yeah.
Number 7.
In a combined total of 54 trials, the dogs correctly identified this specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? So, provide strong evidence that the dogs can detect bladder cancer or little evidence.
Strong evidence if it's unlikely, right?
Yeah, what did it.
It's very unlikely.
It's like the p-value. Ah, just kidding. I'm thinking like. Ah. Well, okay, if they had like a 0.143 chance of choosing it correctly, and out of 54 trials they got it right 22 times.
Mhm.
I think, I mean, that might be strong evidence.
I feel it is, personally.
Yeah.
Yeah, I agree.
Yeah. Okay. Yeah. Because that accumulated together would be like a 0% chance that it would occur that many times over. But I mean, yeah.
Yeah,
right.
unless it's a lucky day.
Yeah. All right, Brianna, you want to go?
Sure. M&Ms are small chocolate candies, in case you didn't know. The M&M's website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? Okay.
Is it really just like what they 0.13, or are we supposed
Yeah.
to be calculating?
Yeah.
Yeah, I guess. I'm like, I keep really thinking about it because I'm like, are they looking for something harder than that?
I think the next one is probably the harder one, maybe. Let's see.
Yeah. Okay. Okay, what is the probability that a randomly selected candy is green? So we just need to add up all of those ones and
Yeah.
figure out what we need to do. Okay, -1. Okay. Did you guys get 1 or 0.16? Whoops.
Sorry.
0.16 maybe for green?
Let's see. Yes, I did.
Okay.
Yeah.
Good. All right. And then the next question. We're on a roll, guys.
What is the probability that a randomly selected candy is not green?
That'd be
So it's
point
The 0.84.
the other one.
24. Yeah. Perfect. That's what I got. All right, and then Brianna.
All right. The ACT scores of students admitted into medium-sized public university in the western United States were taken from CAPEX.com. The following summary statistics were calculated. Use the information in the public university to answer the following questions. Half of the observations were less than or equal to what number?
24.
Yeah, would it be the median? So 24?
Mm-hmm.
I believe.
Cool. This is exciting. If we get any of these wrong, I'm just going to be like, all right, and then number 12, based on the information on the table, the top 25% of the students scored above what number? So it would be like 27 would be the top 25 and above.
Yeah. Mm-hmm. Yep, that's the one.
27.
Okay. Which of the following statements is not one of the three rules of probability? The probability that an outcome will not occur is 1 minus the probability that it will occur. Probability is a number between 0 and 1. If the probability is high, then the probability is positive. Okay, it's that one.
Yeah.
I think, yeah, that it's the high or low one is the wrong
Yeah.
one. Okay.
Yep.
Yeah.
Cool.
Okay.
Cool. Okay, submit.
Do you feel good about these? You submit it?
I think so, unless I missed a decimal. Let me check. I just gotta make
Yeah,
sure.
it's okay. Yeah.
Does it matter if you put like 0 point whatever the answer was, or just
I'm
point?
sure it doesn't matter.
Okay.
I hope not.
I think as long as you have the decimal in there, it should work. But if we do get marked wrong on that, remind me to send a really good email.
Okay.
Okay, ready?
Yes.
Ready.
Submitting. Yay!
Woohoo!
Gosh!
We did good, guys. We did good in a short amount of time, too.
Oh, cool. Yeah, that only took us a half hour.
Yeah.
Yes, guys. Okay, that's awesome. Okay.
Sweet.
So, okay, so for that, what was I thinking? Hold on one second. Okay, so we're just gonna meet on Wednesday at about, I mean, do you guys want to do 6 again? Or do you want to do earlier? Because that's the day I have off. So whatever time works for you guys that day will work for me.
I'm
So-
fine with this time.
Around
Yeah.
6-ish?
So Brianna, you're on the East Coast then?
Yeah.
Okay. I'm on the West Coast. So where are you, Kaylee?
I'm in
Just-
Provo, Utah.
Okay, so
I'm
we're
Mountain Standard Time.
Okay. Well, yeah, I can do it whenever.
Are you sure? Okay.
Huh?
So do you guys just want to, let's do Wednesday at 6 o'clock and get it done this quick too?
Yeah. Good.
That's
Hopefully
it.
it won't be hard.
Okay. Awesome.
Oh,
Okay.
perfect.
All right. Well,
Yeah.
I'll see you guys then.
All right. See you
Okay,
Wednesday.
bye.
Bye.
Bye.